Section 2.3, elementary statistic. On the previous sections, 2.1 and 2.2, I explained about different type of histogram or bar graph. You know, this is a normal distribution. It's kind of symmetric. Half of information is on the left, the other half is on the right. As you see, all the frequency are increasing to the peak and then drop. But this is a uniform distribution. This one is distribution to the right. It's good to the right. It's good to the left. So different type of histogram that we discussed before. And then we also went through these examples on 2.2 and explained about if you get a bunch of data, like 40 set of numbers, how do you come up with a bar graph, which was produced like that. Now, I want to show you a different method of graphing this. This vertical one is a frequency versus the classifications. So one method, they call it stem-elif. So what it does, we go through the number, and like here, there are two numbers, right? Like 76, 72. So the first digits from the left are 7, 6, 8, 9, 10, and here you get 124. So the first two digits from the left is 1, 2. So we list those numbers here: 6, 7, 8, 9, 10, 11, 12. So even if there is a number that doesn't exist, but we want to make sure our stem has all the numbers inclusive here, okay? And then what you do is you could start from the left and just say, okay, this is 76, so 76, 72, 72. Now, this is in case all the numbers are already in order, but the example we had here, numbers were not in order from the lowest to the highest, right? So it goes from 76 to 72, 88, so numbers varies. So in that case, if the numbers vary, you could use this kind of left. Means we start from left, and all the number that the first digit is 6, we tally those, okay? Like the very first number when I go from left to the right is 60. So the first digit is 6 and then 0. The second number is 68. 68. 64. 64. 68 twice. 68 twice. And again, there are 68 and 68. So 68 and 68. Then I reach to 64. And when you count the number, you could cross a line. 64 and 64 would be 64 and 64. Then you reach to 60 and 60. So it would be 60 and 60. And the last number that the first digit is 6 is 64. So that would be 64. See, you list all the numbers that the first digit is 6, list here. Like how many do I have? I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 numbers. So you make sure that those numbers come here. 1, 2, I think it's 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay. Then you start all the numbers that the first digit is 7. So you start here. The first number is 76. So I tally that. 76. Then it's 72. 72. Then it keep another 72. 72. You keep doing that, okay? There are numbers that the first digit, there is a number that first digit is 9, but there is only one, and that is 96. So when I look here, I try to find 96 is right there. 96. There is only one number that the first digit on the left is 9, so it's 96. Then which number start with 10? 100. The only one is 104. I have it here, which is here. So it's just one number. There is no number that starts with 11. So 11 is blank, but you should still have it here because we want to make sure that we have all the numbers that start from 6 to 12 in order here. So even if you don't have it, it has to be plugged. And then 12, 124 is the only number. You put that one here, right? All right, so when you do that, then if you turn it, then that gives you the histogram. Is the one that we actually, on the previous part, if you remember, we were doing all those calculations to come up with a histogram here. Okay? We were doing all this. We have to put the classifications and draw the frequency to come up with this. So if you turn that, that is the stem and leaf. So that's what we have here. Okay. And as I said, one good thing about the stem and leaf is the numbers do not have to be in order. But in this example, it's different. When this person wants to do it, first what he did, he write all the number from lowest to the highest. He went through this and tried to write the number from lowest to the highest. You don't have to do that. But if you do that, then you could just come up with the same graph. It just takes more time. So one of the advantages of a stem and leaf is numbers do not have to be in order because we just try to graph. We want to graph and come up with a histogram. And then normal distributions. So that's the stem and leaf that you keep going from left to right and tally the number that the first digit is any of these. Another method, they call it Pareto chart. We worked on this example before that there were 40 students and we randomly select 40 students. We ask them what their majors. Now, if you want to draw the bar graph or histogram, if you go from the highest to the lowest, they call it Pareto chart. Okay, the only difference is you just look for the one that is highest, and then next one is 8, 7, 6, 5. You just write it in this order. So you have some kind of chart or bar graph like this. Pareto chart is always a skew, is the tails go to the right. That they call it Pareto chart. So you put it from the highest frequency to the lowest one. To be writing in order. You see, 35%, 20%, 18%, 15%, everything is in order from the highest to the lowest. That's the only difference. It's not like you have a chart or a bar graph that are different. You write it in order of the frequency, the highest frequency and the lowest frequency, and then you draw your bar graph. That's another method they call it Pareto chart. Because sometimes people, when you present that to the audience, they see it that the highest is right here and the second is this one. It's easier for people to see it because now they understand that, hey, biology has more interest than like business, for instance, okay? Or they look at, so, economic is almost in the rank number 3. Based on that, whoever is scheduling, it decide to open more classes for this guy here, which is biology. And they said the lowest number, this is just an example, it's not true. The lowest example is people who are interested in business, so they opened less classes on business. See, that's one of the advantages of Pareto chart. When you schedule, when you collect all the data based on raw data, when you collect all the raw data and you analyze it, then you present it. This is a final product that you present to your boss. And based on that, he could tell, for instance, it could be from who had, number of people in workplace that are highest salary versus lowest salary. You always, instead of bringing the data, which is not easy to understand for some people, you always present the graph. It's easy to look at the graph and tell, oh, okay, so most people are in this category and less people are this. So that's another method. This is the color ones. And another one, they call it pie chart. You know, they used to have this for the stock, but sometimes it's not that easy to graph it because you have to know how to do the angles. But this is another method. You put the percentage, you know, like, hey, you look at here, and France are 47%, and this low or low. But in order to come up with the angle, you always multiply your percentage by 360, and shows in these examples. And you could read a copy of this on lecture notes and see how it works. They call it pie chart. These are different ways of presenting your informations to the audience or whoever your boss is. You could either use the Pareto chart, pie chart, and this. The last method is they call it dot plot. Let's say we give you a bunch of numbers and we ask you to graph those. So for this, we go from left to right. 70. Do I have any 70? Yes. You put one circle. 65. You put one circle for 65. Another 65. You go for the second circle. Then 75. You draw one circle for 75. Another 75. Two circles for 75. 65. You go back to 65. You put one more circle. So far I have 1, 2, 3, 365. Then you continue 70. Okay, you add another. And then 75, you put the circle for 75. 80, two eyes. 80, two eyes. 70 again, you go back, add another circle. 70, one more circle. So far 70 has the highest. 50, they call it, this is a number further from any other number. And then 85. 85, just one circle. So based on that, you could graph. You could just see that the highest is this, then this two, and then so on. Okay. They call this number outlier because it doesn't really further from any other numbers. And most of the information, when you want to graph, you try to eliminate that because it doesn't consist with that. So the dot plot resemble a bell shape. It's a bell shape in a normal. If it looks like a bell shape, then it's a normal distribution. Frequency increase to the max. Frequency increase to the maximum, and then drop, decrease. Half of the information is roughly mirror image of the other half. So it's like normal. So normal distribution is the frequency keep increasing till reach to the peak and then drop. So that's another method. And based on this method, then you could do the homework problems. Like in these problems, they ask for dot plot. They want you to take these and graph it and see which one of this is correct. You know, sometimes you got to tell, like, look here, I said, do I have any 60 here? I don't have any 60. So that would eliminate these two right away because these two, they have 60 and 55, 60, but these two do not have 60. So the answer is has to be between these two. So I need to compare these two together. Like this one, the highest number is for 80, but this one, the highest number is for 70. How many 80 do I have here? Not many 80, but I have more 70, so that would be number 8. So you got to look to see which one of those graphs represent that based on this information. And then they have asked some questions. So what I did was I put the right answer for you below. So you could practice, you could hide this one and then read the information and then find the correct answer here, okay? These are another construct a stem plot in your homework. These numbers are given. You have to find which one of these stem plot represent that. You know, it starts with 68. So obviously it's not this one. This one has 65 in it. So it has to be one of these three. They all have 68. 72. They all have, these three, they all have 72. 85, 85, this one has 85, this one has 85, this one has 85. You could also circle it too. 75, we have 89, 88. This one doesn't have 88. See, that would eliminate one. So you could just eliminate some of this by checking on these numbers, or you could go ahead and graph this to see which one of this is the correct one. This is another one. Which one of this is? So for these, I want you to look at, these are very easy to do. You have to just check to see which one is the correct answers. And then on the next page, I put the solution for you. So you could practice on that one. And then you have questions, obviously, you could ask me during the class. And this one also, they want to know, they ask you to do Pareto chart. See, there are our Pareto chart. Because Pareto chart is when it goes from the highest to the lowest, right? So it's obvious that this one cannot be, because it's not, it has to start from the highest to the lowest, not these two. Right there, eliminate these two, so you have to pick between C and D. Again, Pareto chart definition is you go from the highest frequency to the lowest one. All right, which these two are pretty close, and then you look at the numbers. Look at the numbers to see which one would match that. And then I have the solution here for you. Like this one, other is higher than that, or plagiarism for this one is higher, okay? And when you put the number together, for 447 errors, right there, 447 due to the error, right? Error is the second one, so obviously this one is the highest than that. So right there you could tell is this, because the number of error is higher than the other ones. Again, this is another example of Pareto chart. Based on this, you could tell. So remember, in Pareto chart, you have to have order. The highest one has to be H because it's 270, then E, executive search, then mass mailing, and then finally networking. So it has to be in this order. So N has to be the last, and M has to be next to N. All right, so that's why we pick A as the answer. Another one for Pareto. Sometimes when you see the problem is in the color is easier, but since you make a copy, you don't see it that way. But I think when you look at the MATLAB homework, it's very clear which one is which. So this is the answer for it. We are talking about points between 24, 25, 34 is 63. Which one of this graph has those points? So what you see here, for instance, I put the numbers here. You have 63, 255, 755, and 670. So based on these numbers, 63, 255, and then 670, and then 751, and then 670. It goes to the highest and then drop to see which one would match that kind of distribution. So you have to read off of the graph, right? So here they say A is correct, that they're saying that this is 757. So based on the scales, a scale is 100 each piece here. So 100, 200, 300, 400, 500, 1000. You could tell which one has number which is 751. So these are the examples that you should be able to read, and the correct answer is right here. And these are just a fill in the blank. So for these problems, I put the answers on the last page. Okay, so that would be for what you really need to understand on section 2.3.